Hello friends, welcome to my channel Power Plant in a Nutshell. The aim of this channel is let my viewers understand the working of a thermal power plant. The channel would be particularly useful for those who are either associated with thermal power plant or want to join thermal power plant in the near future. In my this channel I would be posting videos related to power plant basics. Then I will move on to the different major components of a thermal power plant like boilers, turbine, generators, etc. And in the further down the line I would be also discussing different subcomponents such as mills, fans, pumps, IDCTs, etc. And once I'm done with all these things, then next step is to move on to the different processes such as operation, commissioning, maintenance practices also. And in between I would be also posting videos related to the new technologies which are actually happening in our thermal power plant, as well as the different policy matters which are taking place in thermal power plant, so that the viewers who are watching my channel should be well versed with the different regulatory norms which we are actually facing in thermal power plant. In order to create these videos I have gone through lot of literature as well as discussion with the stalwarts of thermal power plant. And in addition to that, I have also used the 10 years of experience which I personally have of working in a thermal power plant. So, with this, let's start with our video. The utmost basic of a thermal power plant is a Rankine cycle. And if one is clear with the concept of Rankine cycle and what does the I can achieve from the Rankine cycle by analyzing different conditions, then a person can do a great deal of good operations in a power plant. So, the first question one should ask before studying thermal power plant is what is Rankine cycle? So, the answer is now, if I have to talk about the definition of a Rankine cycle in one line, I would say it's just a thermodynamic representation of a steam power plant. But if I have to more elaborate it, then I would say that in steam power plant there are various processes which are actually happening. It's compression, it's expansion, it's heating, it's cooling. So even a single process is also carried out in a multiple stages. So when all these processes are combined together in any thermodynamic chart like TS chart or HP chart or PV chart, we get a cycle. So this cycle is called a Rankine cycle. Now let's talk about the different processes of a Rankine cycle. In a Rankine cycle, there are four major processes. The first process is the constant pressure heating of a water in a boiler to produce the steam. The steam so produced is made to enter into a turbine where it goes a reversible adiabatic expansion process in order to produce the work. After that, at constant pressure, the heat is rejected by the steam in condenser to convert back into the initial stage of a initial phase of water. Then the pumps will adiabatically compress the water back to the initial pressure. In this way, all the four processes are carried out. Now, this diagram, which is a Rankine cycle TS diagram, represent all the four processes which I have just discussed with you. The process 3 to 4 is a pumping process. The process 4s to 1 is a heating process in a boiler. The process 1 to 2s is the reversible adiabatic expansion process, and the process 2s to 3 represents the heat rejection at a constant pressure in a condenser process. Now, in my next slide, I will be talking about the different components of a power plant. Now let's talk about the different components of a boiler. A boiler is basically segregated into three components, which is which are economizers, evaporators, and superheater. Now, the basic distinction part in of these three heat zones is that in economizer, the heat transfer is basically a sensible heat to a water. In evaporators, the heat transfer is basically a latent heat, that is a mixture of steam and water phase. And in superheaters, the heat transfer is basically again a sensible heat, and that is to steam. Now, I think most of you must be clear with the concept of sensible heat or latent heat. And latent heat. The sensible heat is the heat which is given when the phase of a liquid or a fluid is constant. The purpose of this heat is to raise the temperature of a fluid. The latent heat is, on the other hand, is given when we have to do a phase change. The main important thing to note here is that during the latent heat transfer, the temperature of a liquid remains the constant. So, if my temperature is increasing, that heat must be a sensible heat, and if my phase is changing, that heat must be a latent heat. So, now the diagram represents the heat given in boiler in different regions. The part 4 to 5 represents the economizer, the part 5 to 6 represents evaporator, and part 6 to 1 represents the superheater. Now, as you notice one thing, that as the pressure increases, the quantum of latent heat given in a boiler decreases. At low pressures, this quantum is actually the 40 to 50% of the total heat given in a boiler. But as the pressure increases, this quantum reduces to 20 to 30%. And if we go out of this curve, that is in a supercritical condition, this quantum is reduced to almost zero. So all the heat at that point of time which is given in a boiler is re- is actually used for raising the temperature of a steam only. The next major components of a Rankine cycle are turbine, condenser, and pumps. Now, turbine represents the work done. The turbine can be constituted into further three parts or two parts: HP turbine and LP turbine. These are actually the necessary parts, and the IP turbine, which you find it in the uh, high pressure units. Next comes the condenser. The condenser is where the heat is rejected and the steam is converted back to the water. Now, the main culprit of efficiency loss in a Rankine cycle is condenser, because the heat rejected by a condenser to a cooling water cannot be recovered. So, therefore, we have to leave this latent heat out of the system, and since when this steam heat cannot be recovered, therefore the loss is a very large one. Now, the next represents the pumps. The pump is where the water, which is being an incompressible liquid, is used to pump the liquid back to the initial pressure so that the heating can be done in a boiler. Now, I would like to compare in next slide the Rankine cycle with the Carnot cycle. The Rankine cycle has some efficiency, and a cycle main aim is to achieve the best possible efficiency which can be possible. And for any reversible cycle, the best possible efficiency which can be possible keeping the same parameters is the Carnot cycle. If I see a Carnot cycle, then Carnot cycle there are two temperatures which are actually most important, that is T1 and T2. The T1 represents the mean temperature of heat addition and T2 represents the mean temperature of heat rejection. Now, the efficiency of a Carnot cycle is given by 1 minus T2 by T1. If we either decrease the T2 or increase the T1, the cycle efficiency can be increased. So this way, the same thing we will apply to a Rankine cycle and try to achieve or try to suggest measures in order to increase the efficiency of a Rankine cycle. So here what we have done, we have tried to superimpose the Carnot cycle on a Rankine cycle. In this way we have able to achieve the one temperature Tm1 and the another temperature T2. The Tm1 represents the mean temperature of a heat addition and the T2 represents the mean temperature of a heat rejection. Now the Tm, or before going for Tm, I would like to talk about the T2. The T2 of a Rankine cycle is actually limited by the cooling water temperature. This cooling water temperature is actually limited by the ambient conditions which can be possible. So if I have to decrease my T2, I have to set up my plant in a colder conditions where the ambient temperature is very low. But this condition cannot be actually possible because in that case the my coal cost is normally located in a tropical areas where the temperature is not that large. So and therefore the T2 is actually depend upon the location, and if a plant is set up in a colder condition then I will get a better T2, and if a plant is set up in a hotter condition then the T2 is not in my hand. T2 is actually governed by the atmospheric condition. So what parameters which is actually in my hand is T1 or Tm, sorry. The Tm represents the mean temperature of heat addition. More the Tm, better the efficiency. So that's why nowadays the all the units or the power plant thermal power plants units which are coming in service in operational have had tendency to increase the Tm to the maximum possible values. So with this I would like to end my today's uh, video, and thank you for watching my video, and I hope you like the video, and if you like the video please subscribe to my channel. In my coming videos I would be discussing on the different parameters which affect the cycle efficiencies such as superheating, reheating, pressure raising, and at the same time I would also talk about the modified Rankine cycle. So till that time, have a good day and take care.